Kia ora koutou. I'm going to start videoing this year's Pure 3 exam. So here come the first couple of questions. Question 1 was a modulus problem. This is it here. And question 2 was this factor theorem thing with a little bit of a twist at the end. Okay, so for the first question, some of you drew a graph, which you know is my favourite approach, and I think it's pretty easy here. Some of you squared both sides. Those of you who did that, many of you made mistakes with the algebra. So let's have a look first at how we do it with the graph. Okay, so I'll just get rid of this because I started doing this video earlier. If we're working with this inequality, I can either graph this side straight away and this side straight away, or what I did, just cleaning it up a bit before I started, was that I factored out the 2 like this, and then I divided through both sides by that 2 as follows before I did the graph. So we've got the absolute value of x minus 9 over 2 is strictly less than 2x minus 5 over 2. Now I'm going to try and draw a bad graph in OneNote. Let's just see how we go. So you're not asked to draw the graph, so this graph doesn't have to be great, but it is worth trying to get the slope roughly how we want it. So there's x and there's y. Let's first do the absolute value one, the left-hand side one. So this is at 4.5 or 9 over 2, and we know that that's going to have, oh look, I can get it to be just about to the exact degree. So that graph is going to look like this. I realised that in the exam you don't have access to quite that flash ruler, but there you go. So that's that first graph. And now the left-hand side is going to have a y-intercept of negative 5 over 2. So put it about here, but the gradient is going to be much steeper. So it's going to look, I don't know, roughly like this. Okay, so I'm trying to replicate what it's like for you in the exam when you're in a hurry. I would, however, put a few numbers on there. I'd put negative 5 over 2 on there. But then it should be clear that what we're looking for is when is the left-hand side less than the right-hand side. And that means that the values we're looking for are all of these ones. So all I have to do is to solve a simple linear equation, and it's going to be working with the negative side of the absolute value. That means that all I've got to do now is to solve 9 over 2 minus x is less than 2x minus 5 over 2. That gives me 9 over 2 plus 5 over 2, which is 14 over 2 is less than 3x. So 7 is less than 3x, giving me 7/3 is less than x, but you probably would prefer to write it as x is greater than 7 over 3. So there you go, and that question's done. Now, you don't need to do as many steps of working as I've done either. I think that's a pretty clean way to do that problem. It's very clear graphically that we're looking for one region in here. I'm now going to do what some of you did and do it without drawing a graph and just show you what we've got to be careful with. So most people who did it this way did not get the full marks. If we've got this, and I square both sides, I'm going to have 2x minus 9 squared is less than 4x minus 5 all squared. Right, this is where the errors started coming in. I just have to accurately square both sides. So we get this. Always better to work with a quadratic where the coefficient on the x squared is positive. So I pulled everything over to this side. So 12x squared minus 4x plus 25 minus 81 gives me minus 56. Let's divide everything through by 4. 3x squared minus x minus 14. That was pretty disturbing to me, honestly, how many of you then reached for the quadratic formula, because I think we probably, everyone in the class can factorize that just by looking without doing grouping. We're going to have a 3x squared here. Now, let's just see how we can generate a minus 14. Well, if we think about factors of 14, we can look at 14 and 1. It's not going to be that. Why don't we start trying a 7 and a 2? We'll put 7 here and 2 here. It's not going to be that, but it is going to be 7 and 2. So we've got 7 here and 2 here. Let's see. Right, minus 7 plus 6 is going to give me what we want. So you can see that what we've got now is a quadratic inequality. So let's quickly sketch the roots of that. We're going to have negative 2 here. We're going to have 7/3 here. It's a parabola, it's up the right way. So we're saying 0 is less than this. So we want the positive bits. So that suggests that we want x greater than 7/3 or x is less than -2. And that's where lots of you stopped. But we need to go back and look at the problem, which was this thing here. And that x is less than -2 is going to give us a false solution. Because if you think about x less than -2, we'll have this side will be negative, but this side can't be negative. So we have to ditch that, right? It's quite a lot more thinking, I think, than doing it the first way, but your mileage, of course, will vary. Right, next question. So on to question 2, which was first up a really straightforward one about the factor theorem, and then with just a little bit of a cool thing here for part 2. Okay, we'll just go to a new page. So we've got p of x is equal to 6x cubed plus 13x squared minus 33x minus 70. So if x plus 2 is a factor, then p of -2 equals 0. So let's check out p of -2. It's going to equal 6 times -8 plus 13 times 4 minus 33 times -2 minus 70. That gives me -48 plus 52 plus 66 minus 70, which is equal to 0. Therefore, x plus 2 is a factor. Next thing we had to do was to factorize it completely. I didn't use long division. I saw a lot of you do a lot of work using long division, and again, some errors. For me, it was easiest just to match it. So we've got 6x cubed plus 13x squared minus 33x minus 70 is equal to x plus 2. And then the matching bit must have a 6x squared plus a something x. And then to get that -70, we've got to have minus 35 here. Right, so matching. And you can choose what you match on. I matched on the x squared. So 13x squared has got to equal 12x squared plus kx squared. So that's that one and that one. So k is equal to 1. Now that leaves me having to factorize 6x squared plus x minus 35. So you can do this by grouping, or you can do it by looking, or you could do it by quadratic formula. This is probably going to be a 7 and a 5 combo. So let's just try it. Put a 2x here and a 3x here. And it looks like you can just about feel it before you even do it, that you've got a 7 here and a 5 here. That's going to give me something. That's giving me 14 here and 15 here. And I want to have a plus. So it's going to be plus here, minus here. So we're done. That means that p of x is equal to x plus 2 times 2x plus 5 times 3x minus 7. Okay, now the last bit of the question was the bit that was a little bit different. That's why I chose this for the exam. We now have to deduce the roots of this thing here. So if you look at these, they're maddeningly close to each other, and you can see that the coefficients are matching, right? So if we write it out like this, we've got 6 plus 13y minus 33y squared minus 70y cubed is equal to 0. So let's try substituting. Instead of having y, let's have 1 over x instead. So what I'm doing in here is I am just noticing the coefficient pattern, and I'm seeing this and thinking, well, really what I want to have is this 6 be my x cubed. So we'll try a 1 over x substitution and just see what happens. So now we're going to have 6 plus 13 over x minus 33 over x squared minus 70 over x cubed is equal to 0. I'm going to times everything through by x cubed, and look, we get back to what we had to start with. So big happy face, because we know the 3 roots of this, right? We know that we can write this like this. And we get x. So we've got x plus 2, 3x minus 7, 2x plus 5. So x is equal to -2 7/3 or -5/2, and that straight away gives me my y roots. So y is equal to -1/2, 3/7, and -2/5. Now, there were a couple of people who did well with this and got to here and then managed to chuck away a mark by having the negative of all of your roots. Okay, so what we're doing here is we're solving this is equal to 0. All right, thanks for watching. I will, obviously, you'll get your papers back on this sometime next week, but I thought I'd just do some of these now so that you can start to have a look at where you went wrong. Not expecting anyone to watch this until after the Level 3 Calc exam tomorrow. So I'll do some more later on today.